For the beam shown below with constant EI, compute the following deflections by the double integration method at A, at C, at D, at E, and at F. So use only double integration method. This is the figure. So first, let's solve for the reactions. Let's call this By and this one Re. Bx is 0, of course. So summation moment about E equals 0, or moment is 0. So we have By times 10 plus 15 times 3 times 1.5 plus 90, then minus 50 times 6 minus 30 times 12. So solving for By equals 50.25 kilonewtons. Then summation moment B0 or moment B0. So we have R sub E times 10 plus 30 times 2 minus 50 times 4 minus 90 plus 15 times 3 times 11.5. So 10 plus 1.5 is 11.5. So R sub E is equal to 74.75 kilonewtons. Then we set up moment equation for the differential equation up to EF, the last section. So that is X. So that EI Y double prime. So we just, it is applicable for the entire beam. So we just use Y double prime. EI Y double prime equals By 50.25 times X minus 2. Then plus 90. X minus 9 to the 0 because this is 9. And plus Re 74.75 times X minus 12. That's 12, so X minus 12. Then minus 30 times X minus 50 times X minus 6. Then minus 15 times X minus 12 times X minus 12 over 2. So that is 7.5 times X minus 12 quantity square. Then integrating once, EIY prime equals 25.125 X minus 2 square plus 90 times X minus 9 plus 74.75 over 2, so 37.275 X minus 12 square minus 15 X square, then minus 25 times X minus 6 square, then minus 2.5 X minus 12 cube plus C sub 1. So there is C sub 1 because A is not a support, it will deflect definitely. And remember, in the interpretation, C sub 1 is theta A. C sub 2 is delta A. Integrate again, 25.125 over 3 is 8.275 X minus 2 cube plus 45 X minus 9 square plus 299 over 24, 37.275 over 3 is 299 over 24 X minus 12 cube, then minus 15 over 3 is 5X cube, minus 25 over 3X minus 6 cube, then 2.5 over 4 is 5 over 8, minus 5 over 8X minus 12 to the 4th, plus C sub 1X plus C sub 2. We then set boundary conditions when X is 2, Y is 0, so 0 equals, so this is 0, negative, ignore, minus 5, 2 cube, ignore, negative, plus C sub 1 times 2 plus C sub 2. So setting up the first equation, 2C sub 1 plus C sub 2 equals 40. Then when X is 2 plus 4 plus 3 plus 3, 12, Y is 0. So here, so 0 equals 8.275 10 cube plus 45 3 square. X is 12, remember. This is 0 minus 5 times 12 cube minus 25 over 3 times 6 cube. This is 0, then plus C sub 1 times 12 plus C sub 2. So establishing the second equation, 12C sub 1 plus C sub 2 equals, so make this positive, minus 45 times 3 square minus 8.375 10 cube, and that is 1660. Solving equations 1 and 2 simultaneously, we get C sub 1 equals 162 and C sub 2 equals negative 284. So I want you to verify this. You may eliminate C sub 2, then solve for C sub 1 and C sub 2 from equations 1 and 2. Then having found, and we interpret C sub 1 as theta A, C sub 2 as delta A. Therefore, theta A is 162 over EI, and delta A is negative 284 over EI. Next, for the slope and deflection at C, set x equals 6 for the slope here. So EI theta C is equal to 25.1254 square. Ignore negative, minus 15 times 6 square, 0, ignore plus C sub 1, which is 162. So from here we can solve theta C equal to 24 over EI. Then delta C here, x is 6, so EI delta C is equal to 8.375 4 cube, negative, so ignore, minus 5 times 6 cube, 0, negative, so plus 162 times 6 plus C sub 2, which is negative 284. So delta C is equal to 144 over EI. Then next at D, x is 9, so EI theta D into this equation is 25.125 times 7 square, because x is 9, 0, negative, so minus 15 times 9 square, minus 25 times 3 square, ignore plus C sub 1, which is 162. So theta D can now be computed. It is equal to negative 46.875 over EI. Then delta D here, x is 9, EI delta D equals 8.275 times 7 cube, ignore, minus 5 times 9 cube, minus 25 over 3 cube, ignore, plus 162 times 9 plus C sub 2, which is negative 284. So delta D can now be computed, is equal to 176.625. Then at E, just theta, because y is 0 at E. So into this equation, x is 12. So EI theta E is equal to 25.125 times 10 square plus 90 times 3. Then 0 minus 15 times 12 square minus 25 times 6 square, 0 plus C sub 1, which is 162. So theta E is equal to negative 115.5 over EI. Then at F, x is 15. So let's solve for theta F first. Into this equation, take note x is 15. So all these terms are positive. So we use all these terms. So EI theta F is equal to 25.125 times 13 square plus 90 times 6 plus 37.375 times 3 square minus 15 times 15 square minus 25 times 9 square minus 2.5 times 3 cube plus C sub 1, which is 162. So using your calculator, theta F is equal to negative 183 over EI. And finally, delta F into this equation, x is 15. So EI delta F is equal to 8.275 times 13 cube plus 45 times 6 square plus 299 over 24 times 3 cube minus 5 times 15 cube minus 25 over 3 times 9 cube minus 5/8 of 3 to the 4th, and plus 162 times 15 plus C sub 2, which is negative 284. So using your calculator, delta F is equal to negative 498.375. So that's it for this problem.